Action. Okay. All right. Today we're doing lesson 3.1, talking about symmetry and coordinate graphs. So I put you two graphs up here. Okay. This first one, can anybody tell me what family this belongs to? That makes up V. I'll give you a hint. They either make an A or a V.
Oh, I remember those. A vertex.
Absolute value. Okay. Absolute. This is an absolute value. Okay. Does it have symmetry?
Yes.
What is it symmetric to?
The X.
Not itself.
Y.
Like, because
if you flip it over the line, it's the
which line?
The y-axis.
I hear X and I'm hearing Y.
Y.
This is the X.
The y-axis.
This is the Y. All right. To be symmetric, let me say this. To be symmetric, when you flip it, it has to look the same. So what am I flipping it over for it to look the same? Y. If I flip it over the X, it's going to be going down if I flip it over the X. Okay? So it is not symmetric to the X-axis. It is symmetric to the Y-axis. Okay? Now, we are going to be figuring out here in a minute 4 different lines it could be symmetric to, because there's a such thing as line symmetry, and there's also something called point symmetry. Basically, for line symmetry, you flip things, okay? For point symmetry, you turn things, okay? So if you turn it, say 90 degrees, will it look the same? That making sense? Okay. Now, or I shouldn't say 90 degrees. If you turn it 180 degrees, will it look the same? Okay. So, depending on, would that have a point symmetry? Like if I rotated it halfway, would it look the same?
No.
No. Okay. It doesn't, because we're rotating it around this point. Okay, so that point stays still, everything else rotates, and it doesn't look the same. That making sense? Okay, and you know what? I said that. Nope, I said that right. Okay, so you have point symmetry and line symmetry. The 4 lines we're going to test are the X and Y axis, okay? X-axis, Y-axis. And then we're also going to test this line right here. What's the equation for that line? Does anybody know? Y equals X. And we're also going to do its counterpart, this one over here. And what's the equation for that one?
Y equals
Negative X.
Negative X. Excellent. Okay. Those are your 4 lines. You're going to test equations out. You're not going to graph them. You're just going to go off the equation and tell me, are they symmetric to the X-axis? Are they symmetric to the Y-axis? Are they symmetric to the Y equals X? And are they symmetric to Y equals negative X? So you're going to test all 4 lines, okay? But you're going to do it algebraically, okay? It's not like you're going to graph it and just tell me. You're going to actually do it using algebra, all right? This equation, is it symmetric to any lines? No, okay? It has point symmetry. So I won't know if this is going to work, but I'm going to try it. If I, look, okay, so if I turn it 180 degrees, see how good I drew it. Does it look the same? Yes, okay. So it has point symmetry. Now, understand, how many points are there? 3?
Well, that's how many.
No, just how many points
the entire line.
total are there?
Infinity.
There's an infinite number of points. The only point you need to worry about for our lesson is the origin, okay? So when we say it's symmetric to the origin, that's what we're talking about. We're not going to see is something symmetric to 0.11, or we're not going to see if it's symmetric to 0.40, okay? We're only doing the origin. Everybody good? Okay? So we're going to do origin first, and then we'll worry about the lines, because like I said, we got 4 of those things to worry about. Everybody with me? All right, let's try some. These. They're just asking, is it symmetric to the origin? All right. So to be symmetric to the origin, here's what you have to have, okay? Symmetric, oops, Symmetric has two M's. Symmetric to origin. Here's what has to be true. All right. F of negative x has to equal negative f of x. Okay. For it to be symmetric to the origin, f of negative x has to equal negative f of x. Are those the same things?
Yes.
Meh. Where do I put the negative here? In the parentheses. Where do I put it here? Outside the parentheses. So they're not the same. Okay. All right. So here's my first one. F of x equals x to the third. So I'm going to first find f of negative x. That means instead of putting x, what do I put? Negative x in the parentheses. And I simplify that. What would that be? Negative to the third power is still negative. So that's negative x cubed. Okay? All I did was put negative 1 to the third power is negative 1. X to the third is x to the third.
So you always gonna add a negative with it?
Correct. All right. Now I need to find negative f of x. So that means I say negative, and then in parentheses, I put what f of x is. What is f of x? What is it? Not x, it's what?
X cubed.
It's x cubed. And I simplify that. What's negative times x cubed?
Negative X cubed.
Did you get the same thing?
Yes.
Yes. So it is symmetric to origin.
That's it.
That's it.
Can't you just plug x cubed in the calculator?
Yes, you can plug it into the calculator, but as I stated before, we are not using the calculator that way. Okay? All right?
No, we just spend all our money on them, but never use
Don't do that. Yes, ma'am. I sure will. I'm going to explain it doing this one, okay? All right, so we're going to do the same thing. Find g of negative x first. And does it matter which one you find first? It doesn't. Okay, you got to do both of them anyway. So it doesn't matter which one you do first. I'm going to plug in everywhere I see an x. What am I going to plug in? Negative x. So that's negative x on top over 1 minus a negative x on the bottom. And you simplify. So that will be negative x over what's on the bottom now?
1 plus X.
1 plus x. Okay? That's what I'm trying to get. Everybody with me so far? Hey, senior meeting. Don't forget.
Right now?
No, it sent me I just got email. All right? So that's g of negative x. That's we're plugging in negative x for x. All right? Now we're going to do negative g of x.
Why you put a negative in front of the G?
Because you have to do both. They have to equal. Okay? Negative going inside has to equal the same as a negative on the outside. All right? So I'm going to say negative. What is g of x?
X.
Over.
1 minus X.
All I'm doing is taking this and putting it in the parentheses.
I thought it was 1 plus X.
That's what our answer was. We're done with this one. We're looking at the original. Okay? We're saying negative this. Negative g of x. All right? So if we simplify that, negative times x is negative x over 1 minus x. Okay? I'm sorry?
Yeah. You just
No, because, okay, when you distribute, this, what's out front here? We don't write it, but it's there. Negative 1. Well, it's not negative 1 over negative 1. It's negative 1 over what?
1.
Positive 1.
Oh, because
Okay.
negative, yeah.
So when you multiply the negative times the top, it's done. You don't multiply negative times the bottom too. Okay?
So many rules in math.
Because that's, well, it's the same rule you've always used. Okay? So this negative, it can go to the top or the bottom, but it can't go both. Because if it's a negative over a negative, now it's a positive. You're taking the negative away from it. Okay? So only multiply that negative by either the top or bottom, and to be honest, I would pick whichever one's easier. To me, the easier one's the top, okay? And now you can compare your answers. Is this answer, g of negative x, the same as negative g of x? They're close, but does that matter? No, it doesn't matter how close they are. They have to be exactly the same, okay? So this one is not symmetric to the origin, okay? And I'm just writing that out. You can put yes or no when you start answering your questions, okay? You don't have to put all that. Everybody understand? Okay?
I'm just wondering, okay?
Yes.
Why not plug in the calculator? This just seems a little excessive.
Because you may not have your calculator. Or you may be in a college class when they don't allow, the only calculator they allow is a little 4-function add, subtract, multiply,
They don't
divide.
allow a calculator. I'm not
Okay.
taking that class.
Miss Shaw's daughter, you remember Miss Shaw? She had classes at South where the only calculator they had was a little 4-function calculator.
What if you only need like basic math?
Oh, I missed Malin.
What if you only need like basic math?
I never had Malin.
I don't know.
Like if you a biology major?
To be honest, in real life, a lot of graphic designers use it because they want to make sure whatever their code plugging in, they use mathematical equations for their
So
code.
only if you want to be that.
Not only, that's just one example. Don't make me come up with another one, please. I'm on TV. Okay. All right. All right. These
Not recording yourself.
this next equation, if it ever turns, still wait. There we go. All right. Example 2. We are testing the x-axis, the y-axis, the y equals x line, and the y equals negative x line. We are trying to find out, is it symmetric to all of those? Or 2 of them, or 3 of them, or just 1, or none, okay? We're testing, what is it symmetric to? Everybody good? All right. So here's how you do it. You have to memorize this, okay? So the first thing I'm going to do is I'm going to change my original, and they have x and y. I want to change it to a and b, okay? AB equals -2. That is what you're trying to get when you do these, okay? And by the way, this is on page 130, 130. It goes through how to do this, okay? And 129 is where it gives you the equation to plug in, okay? So if it's symmetric to the x-axis, right, okay? What you're going to do is, all right, I'm gonna put right here, x-axis, we're gonna plug in a negative b, okay? A negative b. That's for the x-axis. And so what am I plugging in for x? A. What am I plugging in for y? Negative b. So I plug it in right here. So that's a times negative b equals -2. Simplify. What is a times negative b? Negative ab equals -2. And I compare that to my original up there when I plugged in a, just regular a and b. All right, are those the same? No, so it's not symmetric to the x-axis. Okay, you'll have to remember what you plug in, yes. Okay, so y-axis, let me see, and I want y'all to think back to our matrices section, okay, because there is a parallel here. For y-axis, which one do you think we change the sign of? A. It's negative a, positive b. Okay, so I plug in negative a for x, positive b for y. All right, plug them in. Oops, I forgot my negative. Negative a times b equals -2. Simplify it. What do we get again? Negative AB one more time. So is it symmetric to the y-axis? No. Okay. It's like that TikTok. Nope. Nope. Maybe this will be, yep, whatever, okay. Y'all know what I'm talking about. Y equals X. What you think we do? Okay, close, but no.
Switch them.
Switch them. Very good. You put B, A. So now, when you plug in, what are you plugging in for X? B. And what are you going to plug in for Y? A. So now you're going to say, all right, that's B times A equals -2. Well, B times A is the same as what? A times B. Well, you want it to look like that. Remember, we're trying to make it look like our original up here.
Where'd you get that at?
This,
Out the book?
I made it, okay? I plug in A for X and B for Y, okay? And that just keeps it, helps me. I'm trying to get this. If it's equal to this, it's symmetric to it,
Does that mean?
okay?
Does that mean that all y equals x's are going to be equal? Because no matter what you multiply together, you'll always get the same thing. Like if you multiply B and A and A and B,
You'll still get -2, right?
does that mean that everything's symmetrical to y equals x?
No. That means this equation only so far.
Why though? Well, like whatever you multiply together, you get the same thing. You just switch it around.
Like if you did
Again, but
C and F.
you're not always multiplying.
God, I'm so sorry.
What if the equation was Y equals X plus 2?
Oh.
Well, now if you switch them, you get different things. Okay, so that's what I'm saying. Don't think of this as everything.
Yeah.
This is just for this particular equation. Okay? All right? So it's not a blanket, everything's symmetric to the Y equals X line. Okay, that's not true. All right? So this one, and that's all they're doing. Yes. Yeah, it is as long as they're multiplying and that's all they're doing. They're not adding or subtracting or anything like that. Okay? All right, last one. Y equals -X.
Flip them and then change the sign.
Very good. So -B, -A. They're still flipped, but you just changed they're both negative this time. Okay? So I'm going to plug in for X, -B. Y is -A equals -2. And you
Why is
simplify
A negative?
because you make them both negative. Okay? You flip them and change both their signs. So what is -B times -A? BA, which you can write as AB. So is it symmetric to that line? Yes. Okay?
That's another one called the variable multiplying.
They sometimes call it
Yes.
BA.
Yes, ma'am.
So is it kind of like if y equals x, that's symmetrical to the thing, then also y equals
No.
x?
You have to check all of them because it is possible to be just symmetric to this one and not symmetric to anything else. Okay? That is a thing. All right? You have to check each one. Yes, ma'am. Yes. No, well, it'll give you one and say it'll probably be multiple choice and say which line is this symmetric to. Okay, so it might have more than one answer. You might can circle A and B, that kind of thing. Okay, yes, sir.
Why does x-axis and y-axis have negative AB equals -2?
Well, let's talk about that.
Can you do that with different numbers? We made I used to be very.
Do you have any issues?
Let you shake it.
That's why you
So now just ask me a question so you look really smart on your video.
Thank you. All right, Ethan. Everybody look. Ethan. All right, so this point right here. What is this point? That's 1, 1. This one's what? 2, 2, 3, 3, right? Okay. So if I wanted to flip that over the x-axis, right? So this one would come down here. What would that point be?
-1.
What'd you say?
-1.
So I just flipped it over the x-axis, but which part changed? the y. So when you're doing the x, you're making the y what?
I'm not talking about that.
Okay, what are you talking about?
I'm talking about, it's hard to point. I'll just go up there. All right.
Hold on. Mask up. We're breaking, okay, here we go.
All right. I'm talking about this right here.
Yes,
Why does it have minus AB while these down here just have AB?
because what is b times negative, or a times negative b?
Well, then that's,
Negative ab.
yes.
This is b times a, so there's no negative here.
Yes.
Is that making sense?
Hey, don't put the pencil close to your mouth.
I'm not. There's a mask.
This is gonna make the YouTube.
You good? All right.
I was good.
I thought that was stuff you watch before.
No, that's your desk cleaner every day.
Do you clean your desk after every
Walk
class?
out the door. Yes.
You do?
Everybody good?
Video.
If I want to flip it, I can get rid of it. If I want to flip it over here, okay? So that's now negative 1, right? What changed? Of the what? The x. So I'm flipping it over the y-axis, and I'm changing the x. Is that making sense?
So
Okay.
why? No, I don't.
I remember that from geometry.
These 2 points.
Okay, but like, why are we pointing it? Like, is it everything that we just did? You're putting on the.
No, I'm just using this as an example of why we're making what we are negative.
Oh, okay.
That's all I'm doing, okay? Notice here, see these two?
Uh-huh.
This line right here, right? That's the y equals x line, right?
Yeah.
So notice, what happens to them?
They cross.
Do they cross? What happens to them?
They flip.
They switch.
Yeah.
The x here is the y here, and the y here is the x here. So notice, what did we do when we were testing y equals x? We did the BA rather than AB. You got me? And it's the same thing if I go here. All right, that's negative 1. I just changed both of those, what? Changed both of their signs. And this is a bad example because if you switch them, they're the same number, okay? But you have to switch them as well, okay? So here you're just switching them. Here you're switching them and changing the sign, okay?
I got it.
Awesome. All right, last little thing you got to know, and this is very simple actually. I had teachers that made this hard, but I try not to make things hard. I try to, the KISS method, I know the KISS method, keep it simple, stupid, okay? All right, so even functions. Here's what you need to know. Even functions are always symmetric to y-axis. If it's even, it is symmetric to the y-axis, okay? Odd functions are always symmetric to the origin. Every time, all day, twice on Sundays, okay? So even functions are symmetric to the y-axis, always. Odd functions are symmetric to the origin, always. Now, here's what my teachers in the past made hard. What is an even function? An even function is any polynomial who only has even number exponents. So, example. What's that exponent? What's that exponent?
4, 2,
Be careful here. What's this exponent?
0.
0. Okay, here's why it's 0. There's an x there, but it's to what power? And anything to the 0 power is what? 1. Anything to the 0 power is 1. Okay, so that's why you don't write that x, because it's just 1, and what's 2 times 1? 2. Okay, so understand, if there's no variable there, its exponent is what? 0. All right, now what kind of numbers are 6, 4, 2, and 0?
even.
This is an even function. Okay, yes.
When you have an x, you can write like, hold on. Formulate a question. So if there's not an x there, how can it equal to 1? Because there's not an x there.
Anything to the 0 power is what? 1. So I'm not saying there's 1 there. I'm just saying we could put 1 there if it helps you to think of it better. Okay? All right. Notice the x. Okay, this one has an exponent. This one doesn't have an x at all. So we're just assuming it had a 0 exponent because it's not there anymore. And it's become 1. You got me? Okay? Yes, ma'am.
So like, if it didn't have an x there, would it still be even function if all the x's, like if x were to equal 4, would they still all be an even function if there's no x? That's
If it just says y equals 4,
no, because you're saying like there's like you x'd out the last x,
right?
but it doesn't have an exponent. So if all of those x's were to equal a number, would it still be an even function? Because there's no x there, because you just crossed it out.
So like, let's say x equals 4, would it still be?
Okay, so,
function?
okay, if you're plugging in, if x is not there at all, you're not doing this. Okay? The x will be there. Somewhere. Okay? It's going to be there somewhere. All right? All you're worrying about is what is the exponents of it. All right? If the exponent is even and they're all even, it's even. Okay? It only takes 1. Okay? Let's just say, instead of erasing that, well, I'm trying to erase it. There you go. Instead of marking that out, I just put 2x. Well, now, what's my exponents? 6, 4, 2, and 1. As soon as I get one that's not even, now it's neither. It's not even or odd. Because to be even, they all have to be even. To be odd, they all have to be odd. If you have some of both, it's neither. It's not neither even nor odd. Okay? So all you're looking for is exponents. So down here with an odd function, y equals 6x to the 5th minus 3x cubed plus x. What's my exponent? 5, 3, and 1. Not 0. Remember, when is it 0? When there's no x there. You got me? So that one, that exponent is 1, 3, and 5. All of those numbers are what? Odd. So this is an odd function. Okay? And if it's an odd function, it's symmetric to what? The origin. If it's an even function, it's symmetric to the y-axis. Okay? Any questions? All right? I'm going to show you this on your calculator. All right? So let me pull up. You don't have to write this. I'm just going to show you how this works. Okay? Let me new share. Okay, so I'm going to go to my y equals 4x to the 6th minus, whoa, that's wrong. 4x to the 6th minus 2x squared. Yes? Everybody agree that's even, right? So when I graph it, it should be symmetric to what? Not the x-axis, but what? The y-axis. 6. So let's cross our fingers. Is that symmetric to the y-axis?
Yep.
Yes. Okay. All right. If I put on the end, or if I just change that instead of a 2, let's make it a 3. All right. Now is that even? Nope.
No.
Is it odd? No, it's neither. Okay, so it's not going to be symmetric to the y-axis anymore. Okay, you can see it's a little, it comes down, it's kind of does something funky here. Y'all see it? Okay, it kind of looks like it, but you can tell to be symmetric, it's going to look exactly the same on either side of your graph. Is that making sense? Okay, let's do an odd one. let's see here. What if we got 2, I won't make it too bad. 2x to the 5th plus 3. Okay, so what's the exponent on the first one? 5. What's the exponent on the last one? 1. Are both of those odd? Yes?
There's not an X, so how could it be 1?
Oh, you're right. I need to put x. You're right. It was 0. I'm sorry. Y'all taught me into that. All right. So 3x. Sorry. Now it's 1. Graph. It should be, is that symmetric to the origin? Could I turn that half a turn and it looked the same? Yes. Okay. But if I do like I was trying to do earlier and said it, I mistakenly said it was odd. If I took that off, now we have an odd and an even. So now it's not going to be symmetric to the origin anymore. Everybody understand that? Okay? All right. Hope you enjoyed this video. Have a great day. I gotta come up with a, I know. I gotta come up with like a sign off, you know, like stay above the line.